Okay, so we're simplifying fractions under radicals. We need to use the following property, which is the quotient property of radicals. Okay. There you go. All right. Okay. Now the quotient property of radicals right here is I can take the numerator and the denominator and make two separate radicals. Okay? And if I had this, I can rewrite it like this, as long as these roots are the same. So it works both ways. All right. Now, I would be tempted on this one. You could simplify this, and then simplify some more. But I would be real tempted on this one. If you look ahead a little bit, make this into one fraction instead of one radical, instead of radical over a radical, make it one radical of the fraction. What is 27 divided by 3? 9. What's the square root of 9? Okay, so if you're looking ahead on something like this, you can see that it'd probably be easier to make this into one. Now, I think I do want to show you, when I was doing this, last period, someone took a different route, so I just went with it. Simplified the top, 3 radical 3, and then the bottom, so they kept it split up, and then the square root of 3's canceled out, and you had 3. Okay? So it'll work either way. Now, the second example, that is a cube root. In case that 3 is not clear to you, it's the cube root of x to the 6th over 8. And I am going to split this one up. Cube root of x to the 6th over the cube root of 8. Now we need third powers here, right? To cancel. Now there's a few in here for x to the 6th. I got 1. What else can I do? I got x to the 3rd. I got 3 of them here. Can I do another 3? And I'll still, and that's x to the 6th, right? And then cube root of 8, that's cube root of 2 times 2 times 2. Does everybody see what I was doing with the powers of x here? Making this power match the root. What happens when you have a cube root and a third power? I thought I heard somebody say it. They cancel. Third power and cube root cancel. So that's x, and then it does it again, x, and this is 2 to the 3rd power, right? What's cube root of 2 to the 3rd power? 2. That is correct. So that's x squared over 2. That's the simplified version of this. Okay. Now these are like the fundamental kind of examples here. Now I'm going to this denominator is 2. It's rational. When the denominator is not rational, we need to rationalize the denominator. Okay? And here's 4 examples where that might be the case. So I'm going to split up x to the 6th. I'm going to split up over square root of x to the 6th over the square root of y to the 7th. Okay, what powers am I looking for x here? What's the index? What is the hidden index when it's not written? Say it louder. 2. The hidden index is 2. So I want squares. I want x squared. I got 4. Can I do it one more time? Okay, so I've got x to the 6th. Now let's do the same thing with y to the 7th. There's 2. Y to the 4th. There's 4. That's y to the 6. I need another y, though, for y to the 7. Is everybody good with how I'm factoring this? Thank you. And then square root of x squared is x. Square root of x squared is x. Square root of x squared is x. Square root of y squared is y. Square root of y squared is y. Square root of y squared is y. But I still have this guy here, right? Under the radical. Okay. X cubed over y cubed. That's a y. Radical y, or square root of y. Okay. That is separate. That y cubed, that third power is with the y. It's not the index of that. All right. Now, this is where we need to rationalize the denominator. Okay. How many y factors do I need in order to get rid of the square root? This is a square root, though, this time. I need 2. So I've got 1. I need another one, right? I'm going to put it in here. I'm going to just put it in here. If I need it, I'm going to put it in here. But I can't do it just to the bottom. I got to do it to the top as well. Everybody with me on that? I needed another one down here. So now I've got x cubed square root of y. I got the y to the third here. And what's the square root of y times y? Square root of y squared, which is y, right? So it's x cubed square root of y over y to the 4th power. Now, this wasn't bad. What we had, it just had a radical in the bottom. So we had to work with that. Any questions on that one? Okay. Now, the 4th root of 6 over 5x. What do you think I'm going to do first? I'm going to use this property. What does that mean? How does that write out on this? The 4th root of 6 okay, over the 4th root of 5x. Very good. Good job, you too. All right. I'm going to split up 6 just in case. I may not need to do that, but 6 is 2 times 3. All right. I got 5. Oops. That's a 4. Keep that as a 4. Don't change that root. I got 1 5. How many more do I need if I'm going to rationalize the denominator? I got 1. How many do I need? What's the root, though? I need 4. So I need how many more? 3 more? I need 3 more, which means I got to put them up here, too. It's under the radical. Extend this a little bit. Oops. Okay. I've got an x here. How many x's do I need down here? How many more x's do I need? I've got 1. I need 4. So that means I need to put 3 more, right? And let's do 3 more up here, too. Alrighty. I can't pull anything out of the radical here, right? I don't have 4 of any one factor. Can you give me 2 times 3 times 5 times 5 times 5? Can anybody do that for me real quick? $750, that's the numbers, x to the 3rd, the variable part. And then what's the 4th root of 5 to the 4th? Fourth root of 5 to the 4th. Julian is 5. You got 5 to the 4th, 4th root, that's 5. Right? 4th root of x to the 4th is what? X. There's the best answer. The best way to write the answer. Okay? Any questions? All right, I need squares here, so a squared, because it's square root, right? A squared, I'm at 6. Now I'm at 8. What do I write for my last part? Just a. Yep, good. Now this one, I've got b squared, there's 4. What do I need anymore? Just a b? Okay. Well, let's go ahead and write this. Square root of a squared, that's a, that's a, that's a, and that's a. If I take a shortcut and write a to the 4th here, was that going to throw anybody off? Okay, instead of listing them all.
Oh.
You're good with that? And I got to be careful. That 4 almost looks like the index of this radical, and it's not. It's the a to the 4th power. And then I got a b times b. So there is b squared, but I still have the square root of b. Are we allowed to have a radical in the denominator for simplified version? No, we're not. What do? We're allowed to put something on it, though. What do I need? Let's put another b in. Yes, exactly. But if I put a b here, what do I have to do? Put a b here. Okay? So that's a to the 4th square root of ab. And this is square root of b squared is b, right? B to the 2nd times b to the 1st. That b to the 3rd. Are we good there? All right, one more example. 5th root of 3 over, okay, 5th root of 3 over the 5th root of 2 times 2 times y. Factoring it out, right? So I have the 5th root of 3. Dang. Got a mental block there, guys. I got 2 times 2. What else do I need? How many? It's a 5th root, though. I need 5, so I need how many more 2's? 1, 3. Need 3 more 2's. All right, got to put them up here too then. I've got a y. How many y's do I need now? And I've got 1, so I need 4 more. Okay, I'm going to write this out. 3 times, that's 3 times 8. That's 24, right? 3 times 2 times 2 times 2 is 24. Y to the 4th, that's my numerator. I'm going to write this out this time. This is the 5th root of 2 to the 5th times the 5th root of y to the 5th. So, 5th root of the top, we can't do any more 2. That's 24y to the 4th. What's 5th root of 2 to the 5th? 2. What's the 5th root of y to the 5th? That is it. All right. There are the examples.